Okay, so we're going to talk about the deep dive and hopefully provide the live demo of what this looks like and what it takes to deploy this. I'm Alan Renouf, and I work at Broadcom in our software-defined edge division, focusing on what our customers need at the edge. Okay, so before we do that, let's talk about GitOps, because we spoke about this Git repository and we spoke about creating these desired state files and the infrastructure doing what it needs to. But what does that mean and what value does that actually add to me? The application developers that are watching this probably know the value straight away, right? When you create applications and you store them in a Git repository, there's a number of things that come along with that and a number of ways in which you can optimize your application development. But it might be new to infrastructure people. So GitOps really allows us a method in which we can design every part of our infrastructure that is ultimately going to run at that edge location, and we can design that through text files, through YAML files, through basically a text file that you can say, this is what I want my infrastructure to look like. This is what I want the virtualization layer to look like. This is what I want my vSwitches, my NTP, my vSAN data store to look like. This is what I want my Kubernetes deployment to look like, and this is what I want my applications to look like on top. Because essentially that's everything that's going to be running in our case at that edge location, and we want to make sure that the edge location knows what it needs to run and how it needs to be configured for those times when it doesn't have a connection, so that it comes up and says, I know exactly what you want me to look like because I have these desired state single source of truth, and I can just reference those, deploy what I need to, configure myself like I need to, and if I don't look like this, I'll change myself to look like this. So these are text files. We obviously check these into a Git repository, so we have our first version of these and a first version of what our edge site looks like. And obviously with Git, we can continue to update this. So we have version control. Version control is great for things like auditing, for security people to come in and say, what version of an application were we running out there 3 months ago when this attack became available? Were we vulnerable to that attack, or were we not? They can go back through the Git and history and see exactly what was running at a specific edge location. It also means that our developers and our infrastructure admins can work from their own files and update their own files to make those changes to ultimately what is going to be down at that edge location. We hear a lot about DevOps and about bringing the developers and the infrastructure people together. We see that at the edge as well. Developers are still creating these applications that need to run at the edge. Infrastructure people are still building the platform for these to run on top of. Often there's a lack of communication between those teams. The people that are running these applications will only be able to go down so far to understand what their application is doing, and then suddenly they'll hit a wall. And they'll have to reach out to the infrastructure team and say, hey, I don't have access to that virtualization layer, or I don't have access to that hosting layer. Tell me what's going on. Why am I out of CPU? What's my memory resources look like? All of these kind of fundamental things that they need. We see exactly the same thing. So what we want to do is provide that unique layer that can give them the visibility of everything that they need, whether they're infrastructure administrators or whether they're developers developing the applications that need to run at the edge. So once we have them in that Git repository, we can then start to do fantastic things with our CI/CD pipeline. I mean, initially, we can take a look at those files and we can say, is the YAML structured correctly? You know, that's a great start. It's what I do for my home network. And by the way, I do have my home network running on my product. I have my home automation with my computer vision applications and my sensors. It's amazing how many sensors you have in your house until you install something like Home Assistant and start adding all the plugins in and saying, hook it up to my Wi-Fi or my iPhone or my Tesla or my solar, and suddenly you have this wealth of data coming in that you can automate. I will stop geeking out after actually one more thing. My Tesla tells me, it actually says on my Alexa, hey, Alan, you forgot to plug your charger into your Tesla. If you don't go plug it in right now, you're not going to get to work in the morning. So, you can start to automate these things together as well. And this is exactly what companies are doing right now. I mean, automating and integrating all of these sensors, bringing this data together and providing that extra level of what's needed at that edge location. But anyway, back to that CI/CD pipeline. Yes, you can check your YAMLs. You can actually spin up a virtual version of our Edge Compute Stack host. You'll see when I show you the platform, you can download an OVA. So once you download that OVA and deploy it, it is like a virtual edge device. Guess what? You can do that as part of your CI/CD pipeline. You can say, go and deploy this virtual edge device. Go and deploy these applications and configure the infrastructure on this virtual device the way my infrastructure defined in these files. Once it's up, run a bunch of tests. Is the application up? Am I able to reach the web server? Is it doing what it needs to do? Is it able to communicate with everything that it needs to communicate with? At that point, I'm pretty secure and pretty trusting in the changes that have been made. And they might be small changes, they might be large changes. But at that point, I've run through an entirely new test suite of everything that's going on before I even start to push this out to my edge locations. And then through CI/CD or through other methods, you can start to actually push it out to those locations. Maybe you do a canary push, first of all. I'm saying push, but really it's a pull. Each of these servers will pull from that Git repository. So what you can do is say, okay, edge site number 1 that's close to my headquarters, go and pull that latest version straight away. And then we can be close to it. We can monitor it. We can make sure everything's working. And then we can start to broaden that out a little bit more, maybe 10 sites, maybe 100 sites, maybe 1,000 sites, to start to push that out to whatever we want and however we need it as we develop that.
So that's effectively your regression test is.
Exactly, yep.
And you can configure that yourself, or you call it a canary, well,
yeah,
canary pull, if you like, you know, that might be actually under your desk, just you'll want to see what the outcome of that is, and that could cause a regression.
Yep. Yeah, I mean, these servers are essentially sat there. When I do the technical demo, you'll understand this a little bit more, but these servers basically sat there contacting that Git repository and saying, what do I need to look like? What do I need to look like on a timely basis? So as these files get updated and they go through this pipeline and they're ready and they're actually made available to those edge locations, the next time it checks in and says, what do I need to look like? It'll say, hey, I've got this new file here. It's version 5. You're on version 2 at the moment. Pull it down, make these changes, stand up those applications, change your vSwitch configuration, change whatever I tell you to do so that you're in this desired state.
This is a different kind of a test plan than is typical.
Yeah, absolutely. Okay. Yeah.
But
I think it adds really great value to what our customers are doing. And if you think about the way you need to scale, it's not just about getting that equipment out there and get powered on. It's about day 2. It's about how do I update those applications out there? How do I monitor? How do I keep track of everything and make changes to those infrastructures? How do I update those as well? All of this will be done through desired state.
Alan, this methodology is a continuous deployment methodology for software and hardware configuration. To what extent is the Velocloud component in here? Because the fidelity of your testing in your CI/CD pipeline to your production deployment determines how certain you are that your test is valid for what's going to happen in production. The last thing you want is missing things or not testing things, CrowdStrike, in your CI/CD processes, and then having a widespread outage as a result. So I love that we can do this in software deployed digital twin deployment for the Edge platform, but Velocloud's a really important part of this as well.
Yeah, you're absolutely right. I'm not familiar with the Velocloud deployment model. I'm sorry. I'm focusing on Edge Compute right now. I know that we have this great Velocloud platform and SD-WAN. Chris, do you know what they do? I don't know it enough to tell you what they do around this kind of CI/CD pipeline. I know, in the breakout, we can certainly go into a few more technical details about what I know is coming up.
Yeah.
That will answer some of that question. But Chris, do you know if SD-WAN has any capabilities? Yeah, okay. We're not the right technical people, I'm afraid.
Right, we can hook that into a later conversation, but I think it's a really critical part of the safely deploying automatically into production.
Yeah, exactly. Yeah,
I mean, because you've got to have a path for, as you're doing this deployment, you're deploying those hardware things and you're doing the Git Connect or the GitOps and all the fun things that happen. That connectivity piece has got to happen.
Yes.
Does it instantiate itself on the fly? Or is it something you have to effectively pre-configure and then this flows through it?
I see. Yeah, I mean, basically, right, your Velo Edge device, your SD-WAN device will sit at this edge location here, and we'll be able to make that secure connection and control the types of traffic that actually go through that connection and limit it in some cases if need be. So it's all about providing that actual network connectivity back to where this Git repository is so that those servers can pull that configuration down.
Okay, and then next step of thinking about this, because you did have like cluster-based component versions of this kind of deployment, in the grand VMware of it all, somewhere there's going to be a vCenter somewhere that does your vSAN, that does that kind of thing, correct? Is the idea that that's deployed into the edge, or is that sitting at a remote location in the cloud, whatever, and then managing at scale?
Yeah, so I'm going to talk about single node hosts today, and I can tell you that on a single node host, we do not deploy Virtual Center.
Okay.
We've talked about the edge. We've talked about the constraints at the edge. One of those constraints is running on a small device like this.
Right.
Often 16 gigs of RAM, right? You install ESX, you install Kubernetes, you install vCenter. You ain't running no applications on that device. So, we really on a single node host have gone down the model of purely using as much of that virtualization layer as we need to, or as required, so that we can get to the point where we can orchestrate this without the need for Virtual Center on that single node. Now, when we get to clustered deployments through orchestration, I think we'll be definitely talking about a different model. But when we talk about that model, we're now talking about probably bigger servers, because now you're talking about things like, I want resiliency for my virtual machines, so I want vSAN. So now that's, okay, well, now you need a bigger server altogether. You need something that has maybe like a 2.1 deployment, 2 hosts and a witness, or, we really start to open that up into the different architecture types that get deployed, depending on what the customer needs for resiliency or for storing the data and making sure that making sure those virtual machines and container workloads are highly available.
Okay.
So, Alan, how do you actually validate the state of the host before you push the package or pull the package?
Yep, great question. So that's part of our agent. So that's a great segue to our architecture diagram as well. Let me try and go into a little bit more detail about that, how this works. And then I'll show you the demo, and I'm conscious of time, so I'll make sure that I get to that point. So just quickly, because I will show you in the demo how all this works. Essentially, as we said, you get that single node. It has everything that you need pre-installed. So if I ring a hardware vendor that we work with and say I want 50 edge nodes, it will come with a generic edge deployment already on there and already deployed. At the moment, what you can do is you can go into our UI and you can actually download an ISO, an OVA, or a IMG. So you can mount that through out of bands management or put a USB key in there or deploy it virtually. Essentially, you end up with the same result. You end up with a server that has an Edge Compute Stack image on it. And when you power that on, it does an automated deployment of ESX and of Kubernetes, and then our agents on top of that, and then basically sits there and says, I'm a server, I'm deployed, I don't know who I belong to, but I know that I am an Edge Compute Stack server, and I just need somebody to claim me. So it's checking in with our service, and it's saying, who do I belong to? Who do I belong to? So the infrastructure admin will basically go in there and they'll say, hey, I know there's this server out there. I can identify it via a couple of different ways. I can either take a look at that make, model, and serial number that my hardware vendor sent me in my nice list of 100 sites that I sent it to, and I can register all of those as part of my organization. And then when they come online, this host that checks in says, hey, I'm a server, I'm out there. And it says, well, tell me, what's your make, model, and serial number? And then it matches that, and it knows who it belongs to. So that's step one done. The other way is we have a access token that displays on DCUI as well. Again, I'll show you this in a moment. In fact, my server's been built. You can see as I actually push a key, you can see the screen that you end up with if you have a screen at the edge, because a lot of our customers obviously do not have a screen there, hence the need for vendor model and serial number, because I can still register that server without a screen being attached. If I do have a screen, then I can take this activation key and provide that to the infrastructure administrator. They can basically use that as the authorization. Okay, so the server's now claimed it's part of an organization. Then what you'll do is you'll set up a Git repository. You will provide that Git repository with the information it needs, and you'll set up a site. And then you will say you'll associate that with the hosts that are in that site. And from then on, this host knows everything that it needs to know about where it's going to pull its data and what it needs to be configured to. And it's the actual host that reaches out to that Git repository, not our service, not our management service. So that Git repository could be local to that server, or it could be on some private data center connection, making sure that all the traffic is local.
It says the Edge Cloud Orchestrator is currently only available as SaaS.
Correct.
Is there a plan for deployability for that? Or?
There's absolutely a plan.
Okay. And with the current model, is there an MSP kind of capability to where you can have overlay management across multiple customers?
Yes, there is. So yeah, exactly. So I won't show you that in the demonstration today, but yes, if you're familiar with Velocloud, that's a model that's intrinsic in the actual platform itself. Okay. So we take advantage of that model to allow partners to essentially do what you said. They can they can sign up as a partner. They can create their own customers, and then those customers will deploy the Edge Compute Stack, and that partner can be as much involved or as little involved as they need to be to help manage those services.
Yeah.
All right, so let's stop talking about it and actually show it, shall we? And this is where I take a deep breath and make sure that the live demonstration works. So let me explain what we've got in front of you here. So what I brought in was an Intel NUC. All I've done is literally downloaded the IMG. I've put it in my Intel NUC and I've powered it on. Okay, that's what I've got to at the moment. The Intel NUC is plugged into a router. Also plugged into that router is a camera, which we're hopefully going to use for a basic computer vision application. And we have a mini LCD screen here. This could represent a screen that maybe you see outside of Starbucks, that they show you what your order is. It could be an airport display screen. It could be a full manufacturing line that's not connected via USB, but connected via other means to this server. You know, it's a device connected to a piece of compute that we can pass through, that we can enable, that we can write applications to work with. So let me break out of this and we will go through the demonstration. So everything still works. So once you sign up for our service, we do have a trial mechanism in which you can use. Thank you, Chris. We do have a trial mechanism which we can offer you if you want to try this out as well with your own servers or your own OVAs. But once you sign up, you will receive a URL and you will receive a username and password. Once you sign into that service, everybody that signed in and used Velocloud before will be familiar with the screen that's in front of you right now that allows you to manage your network edge devices, your SD-WAN devices that you deploy out there and use for your networking capabilities. But what we want to show you today is how you can use the Edge Compute. So by simply selecting the Edge Compute tab at the top, I've gone into our Edge Compute Stack UI. Now, there's a bunch of information in here to help get you started. If you click on the Learn More, there is a very secure way to tell that you are not a robot by clicking a tick box to bring up our documentation. AI is not going to beat that one, is it? Okay, so yeah, we've got thorough documentation on every step that's needed in here, but really simplicity is what we've tried to focus on. Make it as easy for somebody to deploy their first Edge site within minutes, not 3 months, as I mentioned earlier on. So yeah, check out the documentation if you need to. If not, just go kick the tires and see how far you get and then read the documentation, because that's what we do in IT. There's also demos in here as well. So if you want to watch a demo of me doing a host deployment from start to end, there's also that in here as well if you get stuck. So the first, it gives you some getting started steps. I've already gone through some of these from this is actually my home deployment as well. So you'll see some of my homework in here. First step is, as I said, downloading that ISO, downloading that OVA, or downloading that IMG, and then using that deployment method to boot your server. Again, all of that is in the documentation on how to do that, how to write that to a USB, and what to do once you hit that power button. But essentially, once you've written the image and you've powered it on, you get to that point where I showed you a moment ago. Everything is completely automated, no manual steps. You just get an end result, an Edge Compute Stack server. So now we are up and running. What we need to do is we need to give it a few bits of information. So we will go in and we will see that I've already got some Git repositories set up in here that I can use for my home site or for the San Francisco site. But we're going to add a new repository in here. So I'm going to use a public Git repository that I've set up for this called Edge Field Day. And there's nothing special about this repository. I've literally just gone in there to GitHub and said, create me a new Git repository. So once that's done, we can provide it with the URL for that, and we can give it the branch that we were on. In my case, I'm using the main branch. Depending on your deployment and the way that you want to configure things, you might have multiple branches, which you can pick from. There's a lot of knowledge that goes into the way that you configure your desired state and your Git repositories. Some of that is in our documentation. We're going to keep it simple today. We're going to keep everything at the same layer and just use some simple files in there to show you the examples.
Alan, is branching in there this kind of place where you manage things like your canary deployment and segmented deployment?
That's all done as part of the actual CI/CD pipeline. So we kind of leave that to you at the moment. We will definitely develop some best practices in the future and some guidelines around, useful tools that we've found or things that you can include as part of your pipelines to ease the deployment of these.
Does the SaaS service itself actually have to have access to the repository?
No, it doesn't. Absolutely not. You'll see as part of this, I never grant my SaaS service access to Git. I'm literally telling it how the server can access Git. So as well, it's the server that reaches out to Git, so not the SaaS.
And this would normally be an on-premises Git environment that's fully secured and compliant with all of my governance.
Yeah, exactly. So we'll give it a basic description. Okay, I've set up my Git repository. Next thing we'll do is we'll go and set up a site. So sites are quite basic at the moment. The principle of a site is it's a location where I'm going to deploy some edge equipment. So in my case, I've got the Santa Cruz site, I've got Ben Lomond where I live, and I've got Palo Alto. We're going to add one here for the Edge Field Day. And we can just give it an Edge Field Day site. We can give it a location if we want to. In the future, this will give us a nice representation on a map as to where all of your edge sites are and give you that instant health information that we collect to tell you where your reds and your greens are. So as an infrastructure admin, you'll come in here and know exactly, okay, where are my problems with my edge locations right now and what are those problems? Are they infrastructure? Are they VMs? Are they Kubernetes problems? Again, integrating all of that into a simple model. Okay, so we've now set that up. We will choose that Git repository that we selected earlier, Edge Field Day, and we will give it a username to access that, and we will give it an access token. The access token in this case is, I've already created an access token because I didn't want to waste time showing you how to create an access token in Git, but this is basically a read-only access token. So what I've said here is I'm going to create a token that only allows you access to this one Git repository, and it only gives you read-only access to that Git repository. So again, like intrinsic security, making sure that we give the least amount of privileges as part of configuration. Once we've done that, we can provide some labels. These labels come in useful later as part of your desired state configuration. If I want to identify a server in a location, I could use the label for that location to actually say, deploy my computer vision app on these locations. So it's essentially a tagging mechanism that we can use here. So I'm going to click Add Site. Once we've done that, you can see that the site has been created, and as such, actually wrong site, Edge Field Day, not Santa Cruz. As such, we automatically create some internal labels as well for you to use. So we give it a UUID for a site, and we automatically tag everything that's in the site name as well. So again, these are labels that you could use once they're down there. Right, So now we've got a site and we've got a Git repository. We need to tell it about our host. Our poor lonely host is sat out there at the moment, waiting for somebody to claim it. It's homeless. So why don't we tell it where it lives? We can click the add host. And as I said, we can use two different methods. We can use the activation key where we provide it the activation key, or we can use the hardware information. And when we select from the hardware information, you'll see a list of all of the servers that are currently supported to run as part of the hardware compatibility list. You'll notice that I am deploying on an Intel NUC system, and the smarter people in the room will say, hey, they're not on the hardware compatibility list from VMware. They're on William Lamb's blog. So you are correct. We can also type our own entries in here because we are interested in the equipment that you are using at the edge. We want to help you get that equipment supported so that we can actually work with you to deploy that equipment at the edge. So feel free to try and kick the tires on your own non-supported hardware, and then talk to us if it becomes yes, we're going to buy thousands of these and deploy them at 1,000 locations. We would love to talk to you about that. So we'll now select the model. The model in my case is I'm going to hit my keyboard here. Is a NUC 10i5. So NUC 10i5 NK. Making sure that matches i5 FNK. Cool. And then I need to input the serial number. The serial number in my case, G6FN. Make sure you shout if I get something wrong. 211 00358. Looks good? Okay. And then we'll give it a friendly name that we can identify it in our UI and through other mechanisms as well. Again, a label. So we'll just call it an Edge Field Day host. Right. And then we're going to say it belongs to that Edge Field Day site that we just set up. And when you come on board, don't give it its own repository. I actually want to use the same one that I'm using for every host in that site. And then again, we can add tags to that to identify that host if we want. Maybe it's got a GPU in it, so maybe we can just say computer vision app equals true, and then in our spec later on we can say only deploy our computer vision app to those servers that are tagged with computer vision app, right? So we'll add our server. If I got everything correct, you will see that this is now a registration in our platform. So next time this server contacts our platform and says, I'm a server, I'm out here, I'm homeless, give me a home, it will say, I recognize your information, you belong to the Edge Field Day site, and you have this Git repository. Now, if I've done everything correctly, when I hit refresh, it should go into this is why we do video backups.
Well, speaking of backups while we wait,
yeah,
is the design for this type of use case that the data generated there at the edge, is it stateless or stateful?
Oh, that's a great question. So again, it depends on the customer.
Mm-hmm.
So we initially designed this to be a stateless platform. We are now realizing that a lot of people like to store data at the edge as well,
Mm-hmm.
as just generate it. So we are working through making it more of a stateful based deployment model as well for those applications that need it. So yeah, the idea is to obviously support both. Yeah.
Do you have any kind of already pre-baked or partnership-based solution for backup? I mean, to be real honest, for those stateful apps?
We don't at the moment. We're actually talking to customers, understanding what they use at the edge and understanding where they back up to at the edge.
Mm-hmm.
So I want to understand more about what that looks like, so that we can work with them to solve that in the future.
Let's talk.
Yeah, love to. Right. So
Alan, before you
yeah.
Going back to my earlier question.
Yes.
So I want to be able to make sure that device has a certain configuration before I accept it into the pool. How do I do that?
You want to make sure it has a certain...
It's got to have so much memory, or if it's stateful, you've got to have so much storage available before I will actually use that as an edge device, because if I don't have that configuration, it will not run my application correctly.
I see. So, I mean, At the moment, the way I see that done is by people actually understanding what their applications are going to look like and buying the hardware so that it works.
But you still want to verify the fact that that hardware that was shipped has the right configuration before you try and use it.
Yeah, the right configuration to me and to Edge Compute Stack is I need this Edge Compute Stack image on it. That is the starting point. All other configuration, I will give it. I will tell it what its networking needs to look like. I will tell it what its virtualization layer needs to look like. I will tell it if it needs to be in a cluster. So really the starting point is I have a server with Edge Compute Stack on it. You need to know nothing else.
So you're making an assumption that what is shipped is the right configuration.
The right configuration to run the applications. Yeah, I mean, obviously there's a lot of architecture that goes into this with customers. We don't just say buy any server. We say to them, what do you need? What kind of resiliency do you need? What kind of applications are you going to be running now and in the future? Are you going to be introducing things like computer vision? You know, do you have GPUs in those servers? There's a lot of work that goes into specing the edge devices.
But you're not verifying that spec before you deploy.
We are not verifying that spec. I think it'd be interesting to talk to you about why we need to do that. I'd love to hear your thoughts. Thank you for your questions. You've given me enough time for my server to reach out and actually say, hey, I'm here. You can see it's now gone to not activated. So it's found that server. It's now put it in my organization. It knows it's part of this. And actually, if I click on that server, I can start to get some basic information about this back. We haven't activated it yet, so it doesn't know about its Git repository. We can generate remote support bundles if we want to and upload them into our platform. It makes support a lot easier when you have thousands of these sites out there and you want to grab the files and involve VMware support to actually help you with what's going on. So we can generate the support log bundles remotely and provide those. And it gives you basic Kubernetes information about what's deployed down there, the version of Kubernetes, and you'll see the worker node IP address become available in a moment. The reason it doesn't have a worker node IP address at the moment is because it doesn't have a Git repository. If it doesn't have a Git repository, it doesn't know that it needs to run Kubernetes-based applications. So it's basically sat there saying, give me something to do. I know I belong to you. I'm not doing much at the moment, but I need something to do. So let's go back to that and we'll activate that server just by clicking activate. Now what that will do is that will essentially tell that server, go reach out to that Git repository and start retrieving your information. So you'll see as I hit refresh, it'll go to active. I'm guessing we're on some kind of slower network here because it's normally a little bit faster than this. Right, it's now active, but if we take a look at our Git repository that we set up, there's nothing in there. There's no information right now. So all it's doing is polling that Git repository. And if we go back up to our monitor section and take a look at the events, we can actually see that the server was enrolled. We can see that we updated the host groups, so we added some tags. We can see that we gave it a Git repository, and we can see that it's now has access to that blank repository, and it's basically reaching out every minute at the moment and saying, tell me what I need to do. So let's give it something interesting to do. What I'm going to do in this, is that big enough for you all to see, by the way? Are we all good here? Yeah, cool. All right, so I'm going to hit the period key here, and that's going to take me into an online version of minimal version of VS Code Editor for my Git repository. So I can start to actually mess around and create files in here as I need to. Again, is that big enough? I can probably zoom in a little. There we go. Right, so I've pre-created some of these files just for ease. If you are looking for more examples, we do have a ECS example repository in GitHub where you can go and you can take a look at things like, okay, what computer vision applications run out of the box? How do I configure my worker nodes? What message bus applications? How do I do monitoring, networking, virtual machines, et cetera, et cetera. But for now, I am going to preload it with some files that I have prepared. So I'm going to take those. I'm going to hurry up a little bit as well because I know I'm running out of time. Thank you, Chris. Once I work out how to, I tell you, Mac and dragging and dropping with the touchpad is so hard. I did it. Okay. So what did we just put in there? Let's go through these real quick. First thing we're going to do is, once you manually deploy an ESX host, you might be used to hooking in there and doing some post-configuration. Giving it an NTP server, time is kind of important. So you can see here how we're giving it a profile and saying the NTP server for my ESX host needs to be this. We can also give it a change to the welcome message as well, so that DCUI, when that comes up and it's in this secure location, isn't suddenly showing people IP addresses, or allowing people to hit F2 and log in. These servers we talked about are often in weird and wonderful places, like under managers' desks or places that are not secure at all. So trying to add that extra level of security to them makes sense. In this case, we're going to add a simple message to it. We're going to tell it it's a Men in Black server and it's our border control server. So you'll see that change in a moment. I'm going to go to the virtual machines first. So here's an example of how we might deploy a virtual machine down to this edge location. And what's more, we're actually pulling it from Bitnami. So Bitnami has a great list of already pre-configured OVA virtual machines out there. You can take those URLs that they provide you, insert them in this spec, and tell it, I want to deploy this. I want to give it a class, and a class is basically a t-shirt size of what I want it to look like, memory, CPU, resource type-wise. And I want it to be powered on, and I want it to be connected to this network, which we've configured as part of our host configuration. So that's a very simple version of how we might deploy an OVA. And then when we get into the Kubernetes side of things, everything should look exactly the same way that you're used to things looking. So, for example, if I'm going to deploy a computer vision application, right here, I'm basically going to say, I want to deploy this Kubernetes application down to my host. Once it is deployed, I want you to stand it up and give it some configuration. Here's a path to the RTSP feed of my camera, and I want you to detect people and cars. Okay, very basic computer vision example here. We can also do things like pass through GPUs if we want to give it that extra need. In this case, I'm just going to be running off of the CPU. We're also going to kick in the edge display that I showed you earlier on. We're going to give it a custom application that I've written that will essentially give it some information to display to show you that we can communicate with devices and attach those devices that are connected to our infrastructure. And what's more, we're actually going to configure our, actually, I'm going to kick this off and then go through what it's doing. So I'm going to give it time to take this and deploy it so that we can go straight to it. And then I'll go back to the worker config. Right, so what I've done there is I've basically said commit these to my Git repository, okay? So the other configuration I have in here is the worker node. So the reason it didn't stand up that worker node is because it wanted to know how you want that worker node configured. So in this case, what I'm saying is don't use the default worker node, which is two CPUs and 2 gig of RAM. Use a worker node that has 8 gig of RAM, because I'm actually going to run more containers on there than you think I am. Give it a little bit more resources. So it's basically going to stand that worker node up. Now, if everything goes well, we can go back to our orchestration platform. We can do a refresh on this screen. I move the zoom control. And we can start to see things happen. So we can see the initial config was actually, the next time the host checked in, it said, okay, I see there's a change. You put some files in there and given me an initial config. That's the commit. And it can see a bunch of files in there and a bunch of containers and virtual machines and configuration that needs to take place. And as you go through, you'll see it start to become more compliant with that configuration until it's stood up that configuration and everything looks good. So let's go over to our screen and we can actually see instantly that welcome message on our DCUI screen has now changed. So we've, one of the things, if you remember, we said go change the screen to our own customer screen. Great, that worked. Our configuration's been applied. We know the ESX part is working. The next part is to understand where our applications are. In this case, I'm not using a load balancer. We certainly have more complex examples where we do use a load balancer and we configure static IPs. But in this case, I'm just using the worker node IP. So what I can do is I can go to my host and I can say, what is my worker node IP? And now it's stood up, it's there. and we can actually start to access those applications that are on that server that have been deployed. So as part of my spec, I said stand it up on certain ports. If I go to my computer vision application and I give it my worker node IP, if it has deployed, which it doesn't look like it has yet, that's always the last one to deploy. Again, this stuff takes time to go down, configure, make sure it knows what it needs to look like.
So Alan, while we're waiting, I've got another question.
Yeah.
So this is all well and good, okay? But in this space, who do you consider to be your competitors, and how do you differentiate yourself from them? What's different about what you're doing to what they're doing?
Great question. Competitor-wise, I don't know. We're kind of a combination of a number of different things. I think we bring a lot of unique values to this. We obviously bring that ESX layer, right? And everything that comes along with it. Everybody's used to ESX. Everybody is happy that ESX can run workloads within a production environment. It's been tried and tested for years, so we're kind of building on top of that. So providing that, but also providing that simplicity model and the Kubernetes deployment as part of this, adding on top the networking components and the visualization layer that we have, the troubleshooting, the monitoring. I think we're really providing a complete edge stack, hence the name, Edge Compute Stack. We're providing everything that's needed for that edge location. So normally when I look at our competitors, I see them kind of in maybe one individual part of that. Maybe they focus on one area of that.
So you are really targeting VMware shops, is that right?
I think initially, absolutely, we're targeting VMware shops, but it's not only for those VMware shops. We're certainly talking to customers that are looking for simple to use solutions at the moment, because let's face it, building your own deployment model like this takes time, and it takes a large team, and it takes a lot of gluing together open source components normally to get to this point. So we're definitely working with people that have gone through that already, and they are fed up of supporting, maintaining, updating that kind of environment. And they just want something that comes out of the box and is supported, and they can ring one support line and say, a part of this has gone wrong. Here's my log files, you go work it out. Tell me what the problem is. We're responsible for the networking, the Kubernetes, the virtual machines, the infrastructure level, all of it. And I'm seriously running out of time. I'm sorry. You got me talking. Okay. So as we go through this, not quite sure why the computer vision application isn't coming up. I did get the IP right. 0.192. Again, it could be the slow connection and pulling down that initial image. Has the display kicked in?
Yeah.
Yeah. Okay. So we at least know it's pulling down applications, and it's hooked into our display, and it's pushed that Kubernetes application on there. So yeah, hopefully you can see that for those people on the call and the stream. My apologies. I was hoping that the computer vision app would have time to pull down and run. Hey, there it is. So we can see our computer vision app, and it's already detecting people because it has the people sign at the top there. So if I kind of, go in front of it and give it a little wave, hello, yeah, we can see, it's not just capturing data, it's actually giving us a time slice of somebody where potentially somebody is in a dangerous area, and they shouldn't be in that area, and therefore we need to review that clip and see if there's any health and safety issues. Insert your computer vision use case here.